previous video, we looked at 3 factors that influence the effectiveness of a lecture in an undergraduate STEM classroom. We talked about motivation, we talked about prior knowledge, and we talked about attention span. Given those 3 factors, as well as all the research about lecturing and active learning, what then are some appropriate roles for lecturers in the college or university STEM classroom? Well, maybe you remember this clicker question that I shared it in our earlier module on principles of learning. This is a question that I ask in my probability and statistics course, designed to really surface this one particular misconception that students often have. And as you may recall, when I ask this question, first I have students answer on their own, responding using a clicker or classroom response system of some sort. Then they pair up and talk it out, try to put their heads together and come up with the right answer. Then they vote again using the clickers, and then we see the bar graph. That I use to lead a class-wide discussion to try to hear some reasons for and against various different answer choices. In this case, there's a simulation we can do. We can flip coins and kind of determine which is the right answer. And at that point, then I will often take to the chalkboard and spend a few minutes going through an explanation of the concept underlying this question. And so there's a lecture piece there, but it comes at the end of the process. What I'd like you to do is to take just a minute or two and think about this question. What makes the lecture at the end of this kind of pure instruction sequence work? Why might that be an appropriate use of lecture, given what we've said about the factors that influence the effectiveness of a lecture? So I liken this use of a lecture to this term that we introduced in the earlier module called a time for telling. And so the visual here is this idea of Mentos and Diet Coke. You put the Mentos in the Diet Coke and you get this nice geyser of Diet Coke happening. And often when you see this kind of demonstration, you're curious to know why it works this way. And so this is, in my mind, kind of the mental image I have for this idea of times for telling. So in this case, the lecture that comes at the end of that peer instruction sequence, I think is an example of creating a time for telling, in that the students are prepared to make some sense out of that lecture, and they're motivated to want to know the answer. So having them engage with the clicker question and kind of make a prediction for this particular instance, that's one way to activate their prior knowledge. The fact that they're talking about it in pairs as well also brings to the surface what they know and what they don't know about this particular example. So we've kind of got that prior knowledge piece going on. And then when they're wrong, or when they see a bunch of their classmates are wrong about the answer, that adds to the motivation level. They want to know why this thing works the way that it does. Finally, I would say that this whole interaction, the lecture in particular, only takes maybe 5 minutes or so. And so it keeps kind of in with the attention span that we know that college students often bring to the classroom. Now, I've tried to use this module on lecturing to create a time for telling of sorts. In the first video, a lot of the first video involved having you answer some questions. And I kind of left you hanging on the answers to some of those so that you'd be just a little bit more motivated and interested to see what the answers were in the second video. So I don't know if that totally worked or not, but I'm trying to use the structures here to create this time for telling so that by the time we get to the explanation part, you're prepared and you're interested and ready to make sense of that. In a more typical college classroom, there's other ways to do this other than peer instruction. Often you can just resequence some activities and create a time for telling. So I know in mathematics often we want to start with a theorem and then we prove it, and then maybe if we have time we'll run a few examples. But students often really are more motivated by those examples, and those are the things that kind of help them understand what the whole theorem's about. So starting with an example, having students work on it for a couple of minutes, getting stuck perhaps, and then coming in with the theorem that helps kind of explain what's going on. It may be the same content, just kind of restructured a little bit so that the time for telling comes at the end of it. Problem-based learning more generally is a great strategy for creating these times for telling. So what are some other strategies for, or roles I should say, for the lecture in the undergraduate STEM classroom? Well, one thing I hear a lot is the idea of modeling expert thinking. Students need to see experts kind of at work occasionally. The visual I have here, you may remember, we actually use that same visual in our module on principles of learning to represent the idea of knowledge organizations, the mental models and connections that help us solve problems. And so if we want to help our students develop those robust mental models so that they can solve problems as well, they occasionally need to see experts in action, making connections, making inferences, doing the kind of problem solving that we want our students to do as well. Now, some caveats here. One, it's very easy to not make visible the things that really count. We talked in an earlier module about expert blind spots. Often we have to really work at making explicit the things that we're doing kind of internally as we solve problems. Also, sometimes students don't realize this is what we're doing. They'll focus on memorizing or writing down notes and not really key into the fact that we're modeling a problem-solving process that we'd like them to pick up as well. And finally, you can't just model expert thinking. Students have to have that opportunity to practice and get feedback on that practice. Often my math colleagues will say, you can't learn math by watching math, right? You actually have to do it. And so there's, I think, a limited role for lectures in this capacity. There's also the idea of storytelling. Some lectures aren't so much lectures as they are stories. The image here is of a kind of old-fashioned radio. I'm imagining the family kind of gathered around and listening to stories that are coming over the speakers. Stories can help students see the relevance of something. They can generate student interest. It could be a personal story that you share. It could just be an interesting case study or an example. I would say be mindful of the attention span here too, right? You don't want to just do stories, but a short story every now and then can be a really nice use of something kind of like a lecture. Finally, the other role for lectures that you see really increasingly in STEM education is a lecture as a first step or as an introduction to a sequence of learning activities. Now, this runs a little bit counter to that time for telling idea, so I want to problematize this just a little bit, but if students have the right kind of motivation and the right prior knowledge, and they're given a fairly short lecture to make sense of, it can be a nice first exposure to something. Where you see this most often these days is in something called the flipped classroom, which is a model that I think it's important that STEM educators know about. Here's the way I think about the flipped classroom. So in the kind of traditional approach, the class time is spent using kind of transferring knowledge from instructor to students, usually through lecture. After class, students then take that and try to make sense of it through problem sets, try to assimilate that knowledge in one way or another. These are terms that Eric Mazur uses to describe this process. In the flipped classroom, the idea is to kind of shift that around a little bit so that the transfer stage, that first step, happens before class, and then class time is used for that assimilation step. Eric Mazur likes to say that second step, that's the hardest, so let's do that together instead of separately. Now, I tweaked this just a little bit. If you're teaching online, then the real factor is kind of the synchronous versus asynchronous piece. And then these terms, I like to kind of broaden them a little bit. So what might happen in the flipped approach is that there's some kind of first exposure to the material outside of class. And then students come to class, and that's when they do the practice and feedback that's so important to their learning to solve problems and build skills. And frankly, there's often something that happens after that as well. So there's some kind of further exploration that happens after the class time. So this is kind of how I think about the flipped approach. And that first exposure piece is a place where often a short lecture can help. Now, when I use the flipped classroom, often I have my students read a textbook instead. Again, for transmission of information, there's evidence that says that reading a textbook and videos are at least comparable. But this is certainly a place where you're seeing a lot of faculty thinking very intentionally about how to use a lecture to get students started in a particular topic. Now, one other note on this, and that's the idea of scaffolding. I think this is a really wonderful metaphor in teaching and learning. If you think about how scaffolding is constructed, you build the first level on the side of a building, and then you stand on that to build the next level, and you stand on that level to build the next level, and so on all the way up to the top. Thinking about the kinds of learning activities that students have, the sequencing, the scaffolding, helping one build on the other, I think is pretty key here. And so if you're going to use a lecture as a first exposure, you have to think very carefully about this scaffolding idea. What's the right next step for the students where they are, and what will prepare them for the next step that happens during class?